Okay, let's get into this. We're taking a deep dive today into the world of classic geometric constructions.
Right.
It's this space where, incredible precision meets really, really simple tools.
Right. It's fascinating.
And looking at the material we have, it's all about how you build these, well, complex shapes and lines and angles with just two things.
Like a ruler and a compass. That's it.
Yeah, an unmarked ruler for the straight lines and then the compass for your circles and arcs. It's pure geometry, really. Elegant.
And the amazing thing is the limitation itself.
Yeah.
You can only draw straight lines or circles with a set radius.
Uh-huh.
But somehow, those simple rules, they unlock so much capability. These aren't just drawings, they're like visual proofs.
Exactly. And the sources, they jump right into the core stuff. Let's maybe start with angles.
Good place to start.
You can make specific angles right from scratch, like the 60-degree angle. That's kind of foundational.
It really is.
The idea is, well, pretty simple if you think about it, equilateral triangles, right?
Exactly. The source shows how you use arcs with the same radius from 2 points. That forces the third point to form that perfect 60 degrees.
And once you have that 60 degrees,
You can build out, make a 90-degree angle, which often involves getting points set up just right so you could draw a perpendicular line.
right.
And then if you cut that 90 in half, bisect it, you get 45 degrees.
And the sources also show how you can copy an angle, like any angle you're given.
Yeah, which is crucial. Again, it's all about using arcs and making sure the radii match up to capture that same opening. The compass is key for transferring distances.
Speaking of cutting things, bisecting, that's another big one.
Uh-huh. For angles, you're basically finding a point that's the same distance from both sides, both arms of the angle.
So you draw arcs from points on those arms.
Yep. And where those arcs intersect, you draw a line back to the vertex. Perfect bisection.
And what about bisecting line segments? That's a bit different.
Similar principle, different application. You're finding the exact midpoint.
Yeah.
The method described, it involves drawing arcs from both ends of the segment.
Okay.
And the key is using a radius that's more than half the segment's length.
Ah, right. So they actually cross over.
Exactly. They have to intersect. Usually on both sides of the line, you join those two intersection points.
And that line cuts the original segment exactly in half.
It does. But here's the really neat part, which the sources highlight.
Yeah.
That same construction, the exact same one, it doesn't just bisect the segment. It creates the perpendicular bisector.
Ah, so it cuts it in half and makes a right angle.
Precisely. Which is incredibly useful.
You can see how that would be. So that feeds into making perpendicular lines wherever you need them.
Absolutely. Whether you need one at a specific point that's already on a line, or if you need to drop one down from a point off the line, same core idea using those intersecting arcs.
And I guess parallel lines come from that too.
Often, yeah. One common way is just construct two lines that are perpendicular to the same starting line. They'll naturally be parallel. It all kind of builds piece by piece.
Which takes us pretty natural to triangles.
Right.
The sources lay out how you use all these basic angle and line techniques to construct specific triangles, depending on, what info you start with.
Like the classic SSS side, side, side. If you know all three lengths,
How does that work again?
you draw one side first, then set your compass to the length of the second side, draw an arc from one end,
Okay.
then set the compass to the third side's length, draw an arc from the other end, where those two arcs cross. That has to be the third corner of the triangle.
Makes sense. It's locked in by the distances.
Exactly. And other methods like side angle side, SAS, or angle side angle, ASA, they just combine these techniques. You might construct an angle first, then
Yeah.
measure sides along it, or draw a side and build angles off its ends.
The sources even get into some trickier ones, right? Like using the perimeter.
Yeah, some clever constructions there, finding vertices using sums or differences of sides, too. It shows the power of the system.
Looking across all of this, what really jumps out is how it all comes back to just a few simple moves.
Totally. Draw a line between 2 points. Draw a circle or an arc from a center with a set radius.
And the whole how is just about using those actions to find new, precise points where lines and arcs intersect.
It really shows that complexity, geometrical complexity anyway, it doesn't always need complicated tools. Just smart thinking with simple rules.
These are like the visual algorithms of the ancient world.
That's a great way to put it, showing these deep truths about space with just, a stick and a string, essentially.
So for you listening, the takeaway here is maybe understanding that these incredibly exact shapes and forms, they can come from the most basic operations.
Yeah, these aren't just history lessons. They're literally the foundation for so much geometry, design, architecture, things we still use constantly.
It makes you look at a simple intersection differently, maybe. So here's something to think about. How is it that just chasing where two simple curves cross each other, drawn with tools this basic, can reveal such perfect mathematical truths about how the world is put together?
It is pretty remarkable when you stop and think about it. Simple tools, profound results.